Welcome back guys into the first episode of making the smallest portable air quality device in the world. This serial will consist of making a project from scratch, so if you like to see more of this content, please subscribe and like videos. As I want to make sure I cover everything, the first part I want to tell you is about how I got the idea for this project. The second part is about how I make schematic and how you can do it. Third part is designing the PCB, the most important thing. And the fourth part is about how to easily order all the PCBs and parts. We also have a lot of topics we will cover in the next videos, like 3D printing and modeling a case. Also, we'll get in touch with programming a device and making a little mobile app so we could connect everything. So, let's start. First, I would like to explain you how I came up with this idea. I live in Sarajevo, and in the winter this city is one of the most polluted cities in the world. So I decided to make this project to raise awareness about the amount of pollution we breathe during the winter. Let's start with our first step. Firstly, I want to list all features what we want of device. We need to have sensors for air quality, temperature and humidity. Device also need to be operated on battery. We also need some kind of lights to show us immediately what air quality is. We also want to be able to program device via USB as well to charge it. And last but not least, we need to have some Wi-Fi and Bluetooth connectivity. For the sensors part, I will use the smallest PM sensor I could find, and it's PMSA003. The size of the sensor is 38mm by 35mm, which is quite small. In addition, I will use BMA2080 as a sensor for temperature, humidity and air pressure. As time goes, probably I will add more and more sensors, but for now, these are the more than enough to fulfill my project. For the battery side, we will use 3.7 volts LiPo battery with circuit to regulate power as well as circuit to power latch device. Charge battery, power the sensors. For the main MCU, I will use ESP32 Pico D4. It's quite powerful, but mainly why I choose it is because it supports Wi-Fi and Bluetooth and it doesn't need too many peripherals to work, which is quite important when we design small boards. Board size will be 35mm by 38mm, which is the size of PMSA003 sensor. We can also program device via USB. We will later use the over-the-air programming. We will also need to have some lights to show status of device, as well to show air quality status. Let's move to the step 2, the making of schematic. I will use EasyAda online software for making PCBs, but why? Before I used Altium, which is a well-known professional software for making PCBs, but it's very expensive and it's not available to hobbyists. I like to make this video for hobbyists and people who want to enter into hardware. Also, what is good about EasyAda is that you can get all parts in your schematic directly from LCSC, which is a site well known for sourcing parts. Quite cool. For some schematics, I like to draw it first on paper, just to be sure everything looks good, so later when I draw it in the software, I don't miss something. There's a circuit that switches between 5 volts and battery. When the USB is not connected, the resistor pulls the P MOSFET low and the MOSFET draining source is conducting, and on the output we have a battery voltage. But when the USB connector is connected, the P channel MOSFET on the gate has a positive voltage, so MOSFET is not conducted between drain and source. But the diode will conduct that voltage, so we'll have 5 volts on the output. We need to mention that the charger is connected directly to 5 volts, so the battery will be charged while the USB is connected. This is a power latch circuit. It's quite simple and it uses only a pair of transistors and diodes. What we want to achieve is when we press the button, device needs to turn on, and if we hold the button, device go into an off state. We can also sense the push button state and use it for putting device into a configuration mode. Next thing I want to show you is reading the datasheets. It's quite complicated but quite cool. You need to read a lot, but mostly all info is here. You have schematic, electrical characteristic, pinouts, and other important informations. When you read all of this, you can start making a schematic. Let's get back into the easy ADA software. First, as you can see, I always make some structures, so I divide the project into smaller groups by some main features. Now, I will show you how we can add component from the LCSC that is integrated into an easy ADA. After adding the part, we will connect everything with the traces. Info on how to connect component could be found on the internet or in the datasheet of the component. And that's how you can make part of schematic. Now, I'll design whole schematic for you. What I also want to mention is different parts packages. We have SMDs and through hole. Obviously for this project we'll use all SMD parts as we need to save space as much as we can. Okay, after all the work it will look quite cool. We have schematic, so we can continue on to the next step, making the PCBs. So let's start with designing a board. First thing you want to do is set PCB size and outline so we can start placing parts on it. Now I will show you how to set design rules for default trace. I put 0.3 mm for default thickness. And for via I set outer diameter to be 0.5 and hole to be 0.3 mm. Always after defining the board size, next thing is to place and arrange component on a board in such a way that it will be easy to connect everything. But we must follow some electrical rules. At the beginning of designing the board, we want firstly to place components that take up the most space. We also pay attention to where to place parts for the power supply, antenna, microcontroller, and etc. I also like to group components by the features before placing it on a PCB. As you can see, I have already divided all components by groups, and when I select components group on schematic, we get it selected also on the PCB so you can easily find out which components go together. We must also mention that this is a PCB with two layers, so we have two sides to work on. Connections are made with the traces. They can be different width and length. The width is more important when we design power parts, as large amounts of current require thicker traces. For this design, default traces will be 0.3 mm, and for power, we will try to go thicker as we can. Connections between two layers are made with vias. Vias are small conductive holes that connect top and bottom layer, so we can run traces on both layers, and that will help us with small space on a board. Now I will fast forward the design of this PCB so we can continue on more important things. Let's talk about ground planes. They are very important as a lot of components need connection to ground, and current path from the component ground to the battery need to be as short as possible. It will be a big mess if we use traces, so we use a big plane that connects everything beside the traces. Big round planes are also used as a big heatsink when you have some components that can get too hot. But let me do some magic to finish this board finally. The board looks awesome. I success to populate all on this small board. We can continue on the next step, ordering. Last thing is ordering a PCBs. For this part, EasyAda has connected with LCSC and JLC PCB, so ordering a PCB was never this easy. With just a press of a button, you order PCBs and parts. Thank you for watching the video. If you liked the video, consider supporting me on Patreon, and don't forget, like video and subscribe onto the channel. Bye!